Hi, everyone, and welcome to this presentation on the open source OpenVDB project. My name is Ken Museth, and I'm joined by Nick, Dan, and Andre. And we've decided to split this presentation in two. The first part is a description of what we've done since we had the last meeting of this type. And we'll talk a little bit about what we're planning to do in the future. So sort of give you a glimpse into our roadmap. So since we presented last year at Open Source Day, we've actually had 4 releases, 2 major, so 7 and 8 was shipped. And we're preparing or proposing 2 additional releases this year. So one of them is still sort of up in the air. We're thinking about an 8.2 release, likely in the August timeframe, but we're definitely going to release a new major version, 9, and we've committed to doing that at the very beginning of November. It's actually more likely to drop end of October. So this is a summary of some of the sort of highlights and features that we've added in the past year. And I think each of us will just take turns. So I'll just call out a few of them. We added new methods to compute signed distance fields and extending properties off surfaces. This is what we call, or is called, fast sweeping. It's quite fast. It's custom or tailored for the VDB data structure. And we also have accompanying subs to do that. Nick, do you want to go next and talk about AX?
Yeah, sure. So we managed to merge OpenVDB AX in version 7.2, version 8, which was awesome. We also managed to get some serious improvements to the volume kernel. So the part of AX that runs over OpenVDB is not OpenVDB points. So we got that into 8.1. So AX as it stands in 8.1 is looking quite good. I know we're going to refer to this later, but if you're interested in AX and the work that was done over the last year, my colleague Richard is going to be doing a part of the OpenVDB course. So check in, have a look at that. It's going to be good. I'll also talk a bit about, so we improved the morphology methods. So those are the dilation and erosion methods. Dilate specifically is now significantly faster for larger dilation steps, and erosion has new neighboring patterns, which is quite nice. And then the last thing I'll touch on is we added the filtering support for tiles in 8.1. So previously with the filtering classes in VDB, they wouldn't respect tiled nodes. Those are now handled properly on like an as-needed basis. So you can smooth VDBs which contain tiles without having to worry about their structure. I think that's it for me. I'll pass over to Andre if you would like to talk a bit about that.
Actually, do you want to talk also about the dependencies?
Oh, yeah, sure, I can touch on that. So since the TSC kind of started back in 2018, we've been tackling this as kind of a priority, trying to remove some of the dependencies that VDB uses. We've done a significant amount of work, I think, reduced boost usage. We removed OpenEXR as a dependency from the core library, but the OpenVDB render binary still depends on OpenEXR. And we're going to keep tackling that. Try to get rid of boost completely. Maybe make things like TBV optional. But it's going to be a large task.
Cool.
So I'll talk a little bit about the extrapolate SOP. So this is a tool that uses a fast sweeping tool to compute the signed distance function of a VDB of a level set, and it allows you to dilate the narrowband of your signed distance function, for example. And also the most useful thing to do with this extrapolate SOP is to extrapolate a field with either a signed distance function or a fog grid as a reference grid. And the field to extrapolate will be extrapolated along the characteristic trajectories of the scalar grids. And I'll pass it to Dan to talk about.
Yeah, thanks. So the Some of the other additions that we've made is looking at different ways of improving some of the CSG operations and speeding them up. Previously, we were limited by any operation which changed the topology of the tree. We were doing in a single-threaded manner. So we found some techniques to be able to multi-thread operations which change the topology of the tree, which includes things like compositing level sets together, union intersection modes, things like that. And as a result of some of the changes that we made there, we also introduced a new VDB merge SOP, which is pretty convenient in Houdini. It's similar to the VDB combined SOP, but it's a lot faster. It has a multi-input, so you can kind of wire together lots of different VDBs, plug them all together, and it'll be a lot faster to combine them. In addition, we also moved over from using CPP tests for our unit tests over to using Google test or G-test. So the majority of OpenVDB now uses G-test, in particular, all the core library unit tests use G-test. And there's been some other kind of restructuring to the repository as well. We've also kind of finally removed all the make files and kind of officially moved over to using CMake and made some sort of small improvements to the website and the documentation and things like that. So yeah, that's what we've done this last year.
Oh, I actually forgot to mention there's another member of the steering committee, technical steering committee, Jeff Late, that unfortunately couldn't participate, but yeah, he's obviously also part of these contributions. All right, let's go to the next one. So this is sort of a tentative list of features that we plan to add to version 9, the next major. As you can tell, it's quite small. I mean, there are not a lot of entries in it, and you know, that's partly because when the point in time when we make a new major release is when we break the ABI, the memory layout, in the grid itself. So all of these, except for the first one, actually potentially break the ABI. So that's why they're part of this release. I just said that, you know, there are not a lot of big entries. I would probably argue that the first one might be an exception. So NanoVDB will probably go into version 9. NanoVDB is a GPU-friendly read-only version of the sort of a serialization of the grid itself. It's in review. If you're interested in more details, you can either follow, there's a talk at SIGGRAPH, and it will also be described in the course itself. But other than that, we're also looking at optimizing the root node. The root node, if you're familiar with the tree structure itself, is unique. It's different from all the other tree nodes because it's the only node that is actually dynamic. And the fact that it's dynamic also means that it's slower than all the other nodes. It's actually a bit of a bottleneck. One way to sort of alleviate that is to use accessors to grab values, then you actually bypass on average the root node. But there's no denying that it is a bottleneck. So one of the things we're going to do is we're trying to figure out how to make it faster. And the idea is to sort of offset it so it actually has fewer entries. On average, we'll probably only have a single entry. Dan, do you want to talk about transient data?
Yes. So we recognized that looking at the different nodes within the actual hierarchy of the tree, there was a little bit of space in memory to store some additional data that we haven't been using, and we recognize that some of the algorithms, it's actually pretty useful to attach a little bit of data to each of the nodes rather than having to put all the data into external storage somehow. So one of the changes we're going to be making is adding transient or blind data to each of the nodes within the tree, and this is for various different algorithms. It's not intended to be serialized, so it's just for various different algorithms that can use this data, can kind of write to this extra little data that we're adding. We should make some algorithms a bit faster to use.
Yeah, so the idea is that you can sort of temporarily attach values or attributes to nodes in the tree through these blind data. You can actually use them for anything. So Nick, you want to talk about, I can't remember who wanted to talk about the EXR, sorry.
That's okay, I can do this one. So as I mentioned before, we're trying to trim down the dependencies VDB uses. This one's slightly different though. VDB has an optional dependency on the half implementation that OpenEXR uses. And for the VFX platform 2022, EXR has moved to version 3. And so we want to be able to support that as well, optionally for the core library and as a requirement currently for the VDB render binary. So EXR3 was a pretty significant change. And so we're in conversations with the EXR guys as to how to approach this one. But we need to get this done for version 9. So pretty committed to doing that one. And then, yeah, Dan, do you want to talk about the comp time stuff?
Yes. So I'm sure as has been a frequent conversation in the past, OpenVDB takes a long time to compile. And in particular, any client, any user of the OpenVDB library also takes a lot of time to compile things. And that's primarily because the majority of the implementation is in header files. So we're kind of deferring to whoever's going to be compiling against OpenVDB to do all the compilation. And we've been experimenting for a little while on some techniques that we can use to sort of pre-compile as much of the OpenVDB library as we can for the different kind of grid types that we support, things like a float grid and double grid and stuff like that. If we can pre-compile as much as possible up front, then it means that once the OpenVDB core library has been compiled, anyone that's compiling against the OpenVDB library will see significantly improved compilation times. So this is still an investigation item. We haven't committed to be able to do this. There's quite a lot of changes required to make this happen, but it's really only something that we can put in place for a major release. So if we don't do this for version 9, then we'll have to return and look at it for version 10 next year. But yeah, the aim is to try and come up with a system that both pre-compiles as much code as possible for all the standard grid types, but also still provides hooks for being able to use custom grid types, both custom value types and also custom grid layouts as well, custom grid hierarchies. And yeah, so this is really just mentioning it because if you are not using the CMake build system to build the core library, the OpenVDB core library, or if you are doing kind of custom grid types that are not part of OpenVDB, it's likely that these changes will impact you. But otherwise, we'll try and do it in a way that minimizes the impact on anyone using the library.
Cool. So this is our current roadmap for the next year. As you can see, one of the major additions is NanoVDB that I described earlier. There's a bunch of tools. There are actually, if you've sort of paid attention to previous years, there are probably some duplications and carryovers from previous years, but we're pretty confident that we can make this list. Do you guys want to dive in and help me out? Actually, I can take a few of them. So one of the things we've actually looked at, it's sitting in the repo. We have a few technical issues, but it's volume sharpening. So essentially, obviously, the sort of the opposite or inverse of smoothing operations. We've implemented these with convolution. We're having some problems with some boost dependencies, but the expectation is that it will drop pretty soon. We're also looking to add faster, so improved, optimized interpolators, and in particular higher order. So right now we go from 0 order to 2nd order. In the future, we will also have 3rd order. Let's see. Feel free to jump in.
Yeah, I can talk about some of these if you like. So for AX, we're looking to apply the same improvements we applied to the volume stuff to execution over points. That's not to say the point execution is slow at the moment. It's still pretty fast. It's just there's a lot of stuff in the just-in-time compiled product that is opaque, and that's causing some slowdown. So we are committed to making those speed ups for points as well. And then finally in AX, we had front-end functions, so users can declare their own functions, and what we're now dubbing context functions. We kind of talked about this before, but the ability to call grid sampling methods, call grid rasterization methods, and have those change depending on whether or not you're using them for points or for volumes. Something else we're looking to do for points, VDB points, is level set surfacing. Sorry, that's kind of level set rasterization, specifically targeted for kind of fluid surfaces. So VDB already has quite a lot of algorithms to do kind of point to volume transfers. This new edition is focusing primarily on VDB points, which doesn't itself have its own rasterization schemes yet in VDB, and would look to support kind of exuberance and average position, smooth position style rasterization from points to a surface. And that work has been done. It's in a PR and supports also kind of the generic sphere stamping as well. As part of that, it will probably also, the framework around this will also support splatting for VDB points. So kind of like velocity rasterization as well, based on kind of like flip style, kernels dependent on voxel widths, and transferring velocity values into velocity volumes. And these two PRs are also, or rather this PR is currently stored on a point statistics PR, which isn't actually listed here, I don't think, but that is aiming to provide kind of generic methods to do point attribute reductions. So kind of totals, averages, kind of min-max, extrema, things like that over arbitrary point attributes. Yeah, if someone else wants to comment on
this. Talk about some of the improvements that we want to do with SOPs. So the VDB extrapolate sub improvements, extrapolation that was released in 8.1 requires either an SDF or a fog grid as a reference grid, and the field to extrapolate will be extrapolated in all directions of the characteristic trajectories of the scalar grid. And this improvement will allow a user to do basically a one-sided extrapolation. This means that in a certain region, the extension field is going to be unchanged, but if the corresponding value of the scalar grid is greater or less than an ISO value that the user picks, then the field will be extrapolated in that direction. And then for VDB filter sub-improvement, we also want to leverage the fast sweeping and the extrapolation tools from 8.1. So by adding an option to extrapolate prior to applying the convolution filter, you can get a more accurate result at the boundary or edge of your VDB by avoiding the bleeding of background values. And then NetSlice VDB Exchange is concrete goal to tackle some of the problems related to distributed computing in VDBs. So this is particularly useful for a distributed simulation. For example, a user may have two different simulation domains with a halo or overlap region that needs to talk and sync with each other. And it will look for a plane slice if a region of the VDB intersects a given distance from the plane, then it will serialize the voxel values and send this as a packet to other VDBs that may live in a different machine, for example. And it also updates a VDB in the halo region based on the packets that it receives from other simulation regions. And I'll pass it to Dan to talk about the rest.
Thanks. So one of the tools that we are looking to try and improve on as well is to improve the resampling speed of mask and bool grids, which are currently a bit of a bottleneck. And it's mainly because the resampling methods are designed around kind of interpolating like float values and integer values and things like that. But for mask and bool grids, because the value is either on or off, it's much easier and simpler to improve on some of the resampling methods. So that's one area that we would like to look at. In terms of VDB points, I've been working for a while on some improvements to merging VDB points grids, and I took a bit of a a sort of sidestep from this to look at merging of VDB volumes and just grids in general, which is where all the kind of CSG improvements and the VDB merge SOP came from. As we move forward with some of that work, we'd also like to add VDB points to that. In particular, the implementation uses the point partitioner, which is the background to how the point index grid works, and uses that to accelerate the ability to be able to just merge grids together. At the moment, you have to, if you're in Houdini or some other application, you have to convert it to a different point and external points data structure and then convert it back again in order to merge two different data sets. So that'll be a new feature, but also we'll be able to utilize that to improve the speed of being able to actually advect or move these points within VDBs themselves. So all of that stuff is coming. We're just kind of gradually working through all the pull requests and getting those merged up. So I talked a little bit about the compilation time improvements already. One of the other areas that we haven't talked about is looking at the math library. So at the moment, VDB has its own kind of math library with vec3 and matrix types and things like that. And at the very least, we would like to kind of swap out the back end of that to iMath or something else, so that we're not necessarily shipping our own bespoke implementation. It's still a lot of the functionality that's in our math library would still be there. It would just be built on top of an inherited class that would come from somewhere else. Aside from that, the VDB merge SOP is still going to have more improvements. At the moment, for merging density grids, for example, the only option is to add them together, and obviously max is a pretty important operation, and beyond that we want to do other topology merging operations and other things like that. So gradually we'll add more and more to that SOP as we work on those things. And then, did we miss anything? Continuing improvements to the website and the documentations. We're going to obviously be continuing with some of the dependencies. Nick, did you want to quickly talk about the single pass CMake stuff?
I'll be completely honest, I don't remember what this one is. I mean, I have been looking into this for other projects actually, and it's not an easy thing to solve. Trying to run, like a single build of make. Depending on what your the generator you're using, it's not an easy thing to solve, especially with make files, to run like a release and debug build. So I think really what I'll say about this one is we are constantly trying to improve the CMake system, and I'll reiterate that no one here is particularly versed with CMake itself, especially on different platforms. Not to point at fingers at particular platforms, Windows, but if anyone else has experience, and I know there is quite a bit of trouble with the CMake stuff on some platforms, and some kind of edge cases would be interested in taking on and listening to how users are currently finding the CMake build system as it stands, and any suggestions for that side of things. Cool, that's it. Yeah, that's it from me.
Cool, thanks. I'll very briefly just mention that the math library overhaul that Dan was talking about is still, we're not sort of yet committed to completely blowing away the existing math library and necessarily adding dependency on an external one, but we'll see where it goes. It probably belongs on the next slide. That is sort of more speculative. Let's see. So these are sort of very a list of very high level, potentially quite large changes that we're looking at. We are not committing to doing it in the next year, but these are things that we're exploring. And again, there are some entries that you might have seen before, especially the first one, multi-resolution grids. We're still very interested in collaborating with Autodesk. Autodesk has some very interesting work in that problem space. They actually have a presentation at a talk at SIGGRAPH describing the multi-res grid, and maybe we can agree on adopting that. MPI is something that we've talked about in the past as well. So the idea to do memory distributed or support memory distributed simulations. There are still ideas to add sort of high-level tools, support fluid solvers. We've talked about potentially adding a two-dimensional version of the grid. We've had a few applications where people have asked for that. let's see, actually, probably a small one, but still important. So today we only have out-of-core support for compression. We don't support in-core compression in the grid, which may actually be a surprise to you. But there are some applications, especially around sort of static data and rendering, where in-memory compression is very useful. In-memory compression, interestingly, is a big part of NanoVDB, but today we don't support it in OpenVDB. But we will probably add support for IEEE halves in memory. Yeah, feel free to pitch in, guys.
I can comment on the Boost Python stuff.
Cool.
This is a relatively new topic that's come up over the last few months. Again, in the spirit of reducing dependencies, Boost Python's pretty mammoth for what it does, and it's a really good library. But we've noticed that people have been struggling to get the Python bindings with VDB working again on particular platforms. So Boost Python comes with a lot of its own dependencies as well. And one of the things that have been pointed out to us as a possible alternative is PyBind 11. So there is an issue to track this. No one on the technical steering committee is currently able to look at this. So we would love contribution from anyone that's interested if this fits in their domain. And yeah, the idea would be basically to swap out Boost Python for a PyBind 11 header-only replacement.
Dan, do you want to talk about the visitors?
Yeah, so there's a couple of things on here I'll mention. One of them is the high-level VDB samples. So we recognize that the VDB library provides a ton of tools, some really cool and really amazing tool set. But all of the tools are relatively low-level tools where you have to actually plug them all together to build something bigger than that. And we recognize that it would be quite useful, partly as a kind of a learning exercise, to have some kind of simple samples that you could run that does a simple fluid solver or things like that, so that people are more easily able to pick up the library without necessarily having to know Houdini or another platform in which to actually leverage these tools to kind of build something bigger than creating some points and advecting them. So we'd just like to put together some samples to help with that. It would also be very useful for us in terms of benchmarks and regression testing and things like that, so that we can, if somebody comes to us with a possible optimization, we can actually kind of demonstrate what the value is in a kind of simple fluid solver example, and kind of profile that and see the impact that a potential optimization would have. I'll also talk about the visitor pattern stuff. So as I mentioned with the other merging stuff, we are looking to move all of the we're looking to adopt these kind of multi-threaded merging operations. And in particular, many of the existing merging and compositing operations go through the tree visitor pattern, which is inherently single-threaded. And what we are in the process of doing is gradually deprecating all of the visitor pattern from the tree itself. And that has a variety of different methods on each of the leaf nodes, internal nodes, and the actual tree itself, and moving as much of that functionality out of the tree and into separate tools, and getting rid of the actual visitor methods themselves. So that process is still ongoing. There's lots of methods which are currently using it, but at the point at which we're no longer using the visitor pattern ourselves, we will start to deprecate and then gradually remove this functionality with kind of alternatives. There's also a depth first node visitor tool which you can use to replace the kind of standard visitor pattern, but it does require re-engineering the code slightly to fit into a slightly different workflow, as opposed to the visitor pattern, which is very much iterator based. So that's kind of one of our big goals over the next year or so.
Cool. I don't know, Andre, do you want to add anything?
No.
No. Okay. Awesome. So I think that actually concludes the first half. So just a small plug. We have a SIGGRAPH course, a long course. I think it's 3 hours, where all of us, including Jeff Late, talk about different sort of technical deep dives, and we have Q&As. There's also a talk dedicated specifically to NanoVDB, and they're actually back to back. But at this point, I think we're sort of turning it over to a Q&A session. So we encourage you to drop questions in the forum, and we'll try to answer them as they come in.
I can read them out if you like, and we can go through the couple that are open.
Cool.
So one for you, Ken, is NanoVDB going to replace GVDB, or what's the status of GVDB?
Yes, in some sense it is. It's not that. Well, it's actually it's a complicated question, because NanoVDB and GVDB are not really the same thing. GVDB is in some sense an attempt to port a full, basically the whole tool set that you will find in OpenVDB to the GPU. I don't think it quite got there, but it got pretty far. Whereas NanoVDB solves a much smaller problem. It specifically looks at problems typically encountered in rendering, where you're dealing with static data. So in that sense, it's not a replacement. But the fact of the matter is that the main developer of GVDB has left NVIDIA, and I don't believe there's more development going on. So in that sense, I mean, you obviously you can continue using GVDB, but I don't think there's going to be a lot of new support and additions to it. So if your problem falls in the same problem space as Nano, I would probably encourage you to use that. But if it doesn't, then yeah, you may be stuck with GVDB for a while. There is another project coming out of NVIDIA that is more. It's more of a potential replacement of GVDB, but it's obviously not out yet. So I guess it's pointless to plug it right now.
Cool. I have one more. Do you have any contact with the Blender Foundation to improve OpenVDB in Blender? We definitely do have contact with people that are part of the Blender Foundation. I don't know what improve. So I personally don't have any experience with Blender, so I don't necessarily know what improve OpenVDB in Blender means. So I guess this would be on them to reach out and specify exactly what they're looking for an OpenVDB integration into Blender, if that doesn't already exist, and then we can flesh out kind of how we could work with them to do that. I don't know if anyone else here has anything else to say.
I think it's a good response. I mean, we definitely have contacts, but we're not working with them. We're not sort of developing specific. We're solving problems for them. So if they think that would be helpful, we're very interested in establishing those contacts. I actually know that there are people looking specifically at Nano from the Blender Foundation. So on that project, I think we're covered really well, but I don't know what the level of support is for sort of the general OpenVDB workflow. I'm pretty sure it has IO support, but I don't know how many of the tools are actually exposed. So if there's anyone out there that's interested in that and have contacts with the Blender Foundation, we'd love to hear from you. I should probably also say we have weekly meetings in the technical steering committee. It's open, so anyone can join. So if there's anyone interested in contributing to the project, that would be a great place to listen in and see if there's anything that you can help with or contribute.
Cool. We've got another one coming. What's the overhead of converting OpenVDBs to NanoVDB grids on the fly? Is it worth redoing the OpenVDB parts such that we have NanoVDB grids from the get-go?
That's a super good question. The overhead is quite low, but of course, when you talk about overhead, you have to say relative to what. So if you have a real-time application, the overhead is definitely, it's there. I mean, it's, let's see, most models can be converted in, 10, 20 milliseconds if they're in memory. But that, of course, is too slow for some applications. The suggestion to use the NanoVDB layout from the get-go is an interesting one, but it's a difficult one because NanoVDB is solving a very sort of limited problem, the problem of a static grid. It can afford to make some optimizations that OpenVDB cannot. So one of the big sort of limitations of NanoVDB is that it's not dynamic in the sense that you can just nilly-willy modify and add values to the grid. Actually, you only have two ways of generating a NanoVDB, either from an existing OpenVDB, which is when the conversion comes in, or there is a tool called the Grid Builder. But actually, in all honesty, what it does is it generates the equivalent of an OpenVDB, meaning it has an in-memory dynamic grid representation that is very, very similar to OpenVDB. So there's not really a performance benefit there. So it is actually very difficult to do what you're suggesting, which is to use a NanoVDB from the get-go. You're kind of stuck with this sort of translation, but it's quite fast in most cases. And the cool thing is also once it's in the NanoVDB layout, it's very fast because there's no fragmentation. So it's very fast to both access, but it's also fast for I/O. So streaming it to disk or reading it from disk is fast. So I guess the question is, what applications can benefit from it? And as I said, it has limitations. It's not a silver bullet.
I just wanted to, any other questions that, please do put them in the Q&A, and we will continue to answer them as they come in. The other thing that wasn't mentioned, so obviously we'd be very open to any kind of feedback or that you have about opening XR3 or any of the changes to the root node, any of the stuff we've talked about. Would be great to hear any feedback on any of those proposals. The only other thing that we haven't talked about so far is that we have recently switched on the GitHub discussions tab in the GitHub repo, which provides a more sort of Stack Overflow style, kind of voting and upvoting different answers and things like that. So that we've got a Q&A. At the moment, we have the Google Groups forum, which we have been using. However, it has some limitations. You have to use the kind of the web browser, and you can no longer embed it inside of, it's not embedded inside the OpenVDB website as a result of a change that Google have made recently. So we're looking at alternatives, and the GitHub discussion seems like quite a natural fit for where we can host discussion, and also to try and clean up our GitHub issues tab a little bit more, so that, that there are things in there that are a bit more sort of decided on, even if we don't have the bandwidth amongst the technical steering committee to implement some of the ideas, we at least can kind of comment on what the implementations would look like if people have time or inclination to add some of those things, and then more kind of keep the GitHub discussions to be kind of questions and kind of other related discussion. So we're still in the process of kind of feeling out whether that's the right approach, but it seems like quite a good platform to host some of that stuff. So I thought I'd just mention that as well.
Cool. So at the risk of potentially annoying my co-presenters, I just wanted to add one more comment about Nano. It actually has one trick up its sleeve that OpenVDB does not have, and I doubt it will ever have, which is compression. So one of the reasons that you might want to use a NanoVDB for things like rendering or for sourcing in simulation is that it actually allows you to do runtime compression. And this is other than the IEEE that I talked about earlier that we will add to OpenVDB. But you can actually reduce the footprint very substantially. We've seen applications where we can reduce it from all the way to like 8x, which is very, very a big jump. So yeah, just wanted to say that. So there's a great comment from Hans Goody. I'm sorry if I butcher your name. It's not a question, it's a comment. So he's a Blender developer, and it sounds like there are some of the level set tools that he is potentially interested in. So yeah, we'd love to get in contact with you and see where we can help. In all honesty, I don't actually know exactly. It would be very interesting for us to know what are the tools, what are what's the sort of OpenVDB workflow that's currently exposed. As you probably know, it's a first-class citizen in Houdini. It's been quite popular, and we would love to see the same thing happen in Blender if there's interest in that. So if there is, and you think we can help, then please reach out.
I'm also curious from the comment here that says that he heard about an expanded set of examples. That sounds quite nice. And I'm wondering if that's not necessarily about Blender integration, but also about the samples, the idea of providing VDB samples with the repository. So like, as I said, like mini fluid solvers or examples of how we're doing consecutive smoothing and, you know, things like that. So yeah, and if it was about that, yeah, that's something that we wanted to do for a while. The documentation for VDB hasn't been updated too much since, well, for a while. We try to keep tabs on the build docs, but in terms of examples with the new tools, it really is just comments in the code. So yeah, it's a big job, but it's something that we're very well aware needs some work.
One other thing related to that is just to mention that the Houdini HIP examples have been updated recently. So if you go to the website on the download tab, there's a new set of Houdini HIP examples that Jeff Bugsberg has been updating, which provide lots more examples as to how to use some of the newer tools in Houdini. So that's a great resource if you're on Houdini and you want to experiment with some of that stuff. It's all available now, and we'll continue to expand that HIP file and add more examples and things like that. And yeah, please do reach out to us if there's any particular tool or SOP where you think extra examples would help. We'd be happy to kind of continue extending that.
If you have any other comments on questions, yeah, I think you can use the Q&A. I think it's only the Q&A we have access to, but feel free to use that to make any comments.
So one of the questions that we always ask, and we've actually gotten some very interesting answers in the past that have led to development, is of course, what are the missing features? What are you missing in OpenVDB? Is there anything, yeah, that you were looking for, couldn't find? Both in terms of high-level tools or maybe even low-level functions or methods. You know, if you prefer, you can definitely shoot us an email, but it'd be interesting to hear some suggestions now as well, if there are any.
One thing I'll add that we haven't covered is we're looking at, this is kind of in the same vein as what Dan previously mentioned, reducing compile times, but it wasn't intended for that usage. But we're going to be removing string grids from the library, or rather deprecating the native support for string grids. They're a bit of a weird one anyway, because they have a bit of a weird implementation. But the important thing here is that the idea would be to move forward with deprecating grid types that are dynamically allocated, or rather that dynamically allocate memory. So things, plain old data types, trivially copyable types will still be supported by VDB, no matter if we restrict that further or what, that will always be supported. But it's the idea of instantiating grids with classes, custom classes that manage their own memory. So yeah, we'd be really interested to hear if people are using VDB with kind of crazy custom types. That would be cool to see.
Yep. No more questions. Is there anything else that we want to share?
I think that's it. Yeah.
All right. Well, if there are no more questions, we may as well end early. But as I said, there's a course on demand, and there's a talk, and there are 2 Q&A sessions next Monday. And if you have questions or comments that you didn't feel like sharing, then feel free to shoot us an email or show up at this weekly meeting that I mentioned. The notes for the meeting, the minutes, are actually in the GitHub repository, so you can go in there and find it, and that's also when the meeting time. And I believe we have a link to it as well. But you can always shoot us an email if you have any questions. Cool. Well, thanks for holding out so long, and hope to connect with you at some point.
Thank you very much, everyone.
Thanks.
Cheers.
Thanks, everyone.